You have to understand 3 different angle relationships to solve problem number 7. 2 out of 3 of them we've talked about a lot, and the third one is something that you'll see when we talk about it here in just a second. The first one we have these 2 angles. Let me mark them. This angle is adjacent to angle X. They're adjacent and they're forming this right angle. That's the key. So if these 2 angles add up to 90 degrees, they're complementary angles. So we can find angle X by subtracting 49.1 from 90. So 90 minus 49 and 1/10. I'll write 90 as 90 and 0/10, creating like terms so we can subtract. I need to borrow here. Line up a decimal in my difference, and 10 minus 1 is 9/10. 9 holes minus 9 holes is 0 holes, and 8 minus 4 gives us 4 tens, so 40.9 degrees. And if you quickly add those back together, 49 and 40 is 89, and then 1/10 and 9/10 is your extra hole to make that 90 degrees. The one that we haven't talked about much is this one, but you see this very large reflex angle, 290 degrees. This angle X would be completing this whole circle. And so you just have to realize that there are 360 degrees in a circle, and subtract 290 from 360. You'll get 70 degrees. The third one, we have this very small acute angle, 19 and 2/10 degrees, and this very large obtuse angle, which together are making a straight line. Straight line starts with S, and so does supplementary. So these are supplementary angles. They add up to 180 degrees, so if you start with 180 and you subtract 19 and 2/10, line up a decimal in your difference, we get 8, 0, 6, and 1. So X here equals 160 and 8/10 degrees. Problem number 8. We're trying to find the unknown angle measurements in each of the polygons. The first polygon, PQRS, is a quadrilateral. All quadrilaterals have the sum of their angles is 360 degrees. We saw that we tore the angles off a quadrilateral and it made a complete circle when we placed all the angles adjacent to each other. So the angles we know are 70, 90. That right angle symbol here shows us that this is 90 degrees, and 50 degrees. 70 plus 90 plus 50 is 160, and 50 is 210. And when you subtract 210 from 360, you get 150 degrees, which looks reasonable for this angle because it's an obtuse angle. So 150 degrees is the answer for angle S. This unknown angle is part of a triangle, and the sum of the angles of a triangle is 180 degrees. So we have 141 and 23. That's 164. And 180 minus 164 is 16 degrees. And that looks reasonable for this angle. It's a very small angle, very acute. Okay, problem number 9. We're asked to draw all lines of symmetry for each picture below. A line of symmetry is a line where if you reflected, well, let me draw one first. Let me take the very obvious one first, the football. If I draw a line here, and I took this part of the picture and flipped it over the line like a reflection, you would get the same image on the other side of the line. So it's a reflection of this part of the image across this line. Could I also reflect this half of the football across? I think I could. So if I draw another line of symmetry here, well, that's not a line. if I draw, oh, I'm having trouble with this thing. If I draw another line right there, right through that middle lace, then I have another line of symmetry for the football. The Starbucks symbol has only one line of symmetry, and it's through the center here, like this, vertical line. This Mitsubishi symbol has more than one, it actually has three. If I draw a line of symmetry this way, I could fold it and it would match all the parts of the picture would match up. Also, if I drew one this way, that would work. And if I drew one this way, that would also be a line of symmetry. The final problem on page 3, problem 10, we're asked to calculate the shaded area below. And you could do this triangle plus the rectangle. I think it might be more efficient to draw a line here and do this whole big rectangle minus this trapezoid. So I'm going to call this area 1 and 2, but for 1 I'm talking about the whole rectangle. Actually, I'll outline the whole thing so you see what I mean. I'm going to start with this entire rectangle and then subtract the trapezoid from that. So the area will, that's not going to work. The area of the whole figure will equal area 1 minus area 2, the difference. Area 1 is just the large rectangle, so base multiplied by height. Area 1 equals the base is 30. The height is 15 plus 10, so 25. So area 1 is 750 inches squared. Area 2 is a trapezoid, so it's equal to half the sum of the bases, 1/2 multiplied by base 1 plus base 2, multiplied by the height of the trapezoid, which is the perpendicular distance between the bases. The bases are the parallel sides, so base 1 will be this distance right here, and since this is 5 and this is 15, that's 20, but this complete distance, horizontal distance is 30, so this must be 10. This base 2 up here is just 30. It's equal to the same as the base of the large rectangle. The height of the trapezoid, this perpendicular distance here, is given outside here as 10. And so when we substitute those into the trapezoid formula, we have area 2 equals 1/2 of 10 plus 30 multiplied by 10. That's half of 40 multiplied by 10, which is 20 times 10, which is 200. So area equals A1 minus A2. So the total area equals 750 minus 200, so 550. Inches squared. And you will get that same area if you do area of this triangle plus this smaller rectangle down here. Or any way you do it, you'll get that same area. Okay, that completes page 3. We'll pick up the review with page 4 in the next video.